name is Cayton.
Hello, my name is Christina Panayi.
And this is our Wireless and Mobile Networks Assignment 3. In this assignment, we were asked to create a wireless network for Nuts & Co, who currently have a wired network in place, but they wish to expand on this with a wireless network to allow both guests and business users to connect to it and use the company's resources.
The first requirement was to have a wireless network with the security of WPA to Enterprise PIP.
The second requirement was that both a guest and a business wireless network should be created to allow the two sets of users to both use the wireless network.
Pings should be blocked across the network. That counts for the client and the server as well.
And filtering is required to prevent staff and guests accessing inappropriate web pages because the company doesn't want their users and guest users accessing sites such as gambling sites and pornographic material.
Another requirement was a captive portal describing an AUP should be an AUP. That means that before the user accesses a website or a web page, they should accept the policy.
And after the initial login process, wireless clients should only be allowed to send HTTP and HTTPS traffic across the network, with the exception of receiving a DHCP address from the server and making use of the radius server for the PIP login.
Another requirement was that VLAN should be used to separate wireless and wired traffic. For this, we used a layer 3 switch.
And the final requirement is that the wireless network should be hardened where possible to block the use of tools like Nmap. This is for security reasons. The following is a diagram of the test network which we use for the assignment.
This is the server which has the services of DHCP and radius using the PIP security. And this is the layer 3 switch where it has the 192.168.10.1 VLAN.
Over here on the wireless side, we have an access point with an address of 192.168.20.2. The wireless clients make use of the server's DHCP, and the range is 192.168.20.50 to .100. And they connect to the wireless VLAN, which is located on the layer 3 switch, which has an address of 192.168.20.1. Up here we have our pfSense router, which provides services such as access to the internet, web filtering, and protection against outside threats. And up here we have the internet itself.
Now let's see the network in action.
The first thing we're going to look at in the demonstration is the access point itself, and as you can see it's set to use WPA2 Enterprise PIP as its security setting, and the radius server is the 192.168.10.254 radius server. We also set up 3 guest networks on the access point itself, and these are called NutCo Guest Monday, Tuesday and Wednesday, and are set to use pre-shared key. We also set up several guest accounts on the Windows server itself, and this was to provide a guest network with a finer level of control than what we would find on the access point. These accounts can be logged into using the same method as the business accounts.
This is a client device trying to access the NutCo wireless network. As you can see, it prompts up with a username and password for the network. And this is the certificate from the server. And now it's successfully connected to the NutCo. This is another client device, an iPad, trying to connect with the same account to the PIP network, and this is the certificate that shows up from the server.
The next requirement is that pings are blocked across the entire network. This was done by using the switch between the access point and the server. As you can see, the ping between the client device that we saw previously and the server. Next is that clients should be blocked from accessing inappropriate web pages on the network. So as you can see here, appropriate web pages such as the University of Central Lancashire website are allowed, but websites such as AutoTrader, 8.8.8.com, which is a gambling site, and Match.com, which is a dating website, are completely blocked on the network.
This is SquidGuard, blocking specific websites such as trading, gambling, hiking, and weapon websites.
The next requirement is that a captive port will be installed onto the network so that when wireless clients connect to the network, they have to sign an acceptable usage policy in order to browse the internet and use the company's resources. We got this working in a very limited form, however it was not possible to implement into the full network due to time constraints and lack of knowledge in this area. Okay, so now let's take a look at the config file used for the switch in the network. Down here we can see that the VLANs have been created. VLAN 10 is for the server side of the network and VLAN 20 is for the wireless side. VLAN 20 has an IP helper address assigned to it, which points to the server which serves the DHCP addresses. VLAN 20 also has the accessed control list applied to it, which we will see in a moment. Up here we can see that the VLANs have been applied to the correct interfaces. And now let's take a look at the access list itself. This access list allows traffic such as DHCP and radius packets from reaching the server, but nothing else, which means that once the wireless clients have connected to the network and have authenticated with the radius server, all they can do is access the internet and nothing more. The final requirement for the network was to block the use of tools such as mmap from affecting the network and compromising their security. So as you can see here, we are connected to the access point and we are scanning the access point itself. And as you can see, no ports have been found to be open. Next up, we're going to scan the server using the same parameters as the access point. And once again, which we'll see in a moment, no open ports have been found and no IP addresses have been found. This is partly due to the firewalls on the server, the access lists on the switch, and Snort, which is running on the pfSense router. Next, let's scan the router using the same parameters yet again. And once again, no ports have been found, no IP addresses have been found.
This is a capture of Snort detecting the Nmap scan from the client device of 192.168.20.52. The network that was implemented for this project was mostly success because of the requirements that were met, with the exception of captive port.
The main problem with the assignment, however, was that no real client requirements were gathered and only a list of features that the network had to have. This meant that the organization's network was unknown, which means that it could not be taken into account fully when developing a test network. The lack of information known about the client's network means that it is nearly impossible to give a solid recommendation as to whether to implement the test network into the real network in its current state.
Thank you for watching.